Okay, so here we're going to do a problem about electric field. We're going to take these two charges, or two charged particles, one that has a charge of plus q and one that is negative 3q. We're going to use them to find the electric field at the origin. Electric field is a vector property, which means that we're going to have to take direction into consideration. We're going to use superposition, which means that the electric field at the origin is simply the sum of the electric field of one charge plus the electric field of the other charge. Now, one of the nice things about this particular problem is that everything's really at nice right angles. So looking at the charge of plus q, we know that it's going to exert an electric field that points straight down. And looking at the charge of negative 3q, we know we're going to have an electric field that points in the direction towards the negative charge. Now, part of the problem is we're going to have to find the relative sizes of them, but we know that the final field is going to be the vector sum of these two charges and will point in that direction. Okay, so let's actually start the calculation. The electric field for a charge is, for a point charge, is kq over r squared. Now, because this charge is positive and it's pointing down, or because the field is pointing down at this point, we need to give it a direction. And we're going to say that it points in the negative I hat direction. So this piece gives us the magnitude, and then this piece here tells us the direction. I'm going to add to that k, and I'm only going to use the magnitude of this charge here. Oops. The distance is 2r, so I'm actually going to be squaring 2r. And because the electric field always points towards a negative charge, this will be j hat. Okay, so the final result will be negative kq over r squared I hat plus 3kq over 4r squared j hat. Now, if we needed to, we could simplify. We could find the magnitude of this by using the Pythagorean theorem. So we would take the x component, square it, add it to the y component, square it, and then take the square root of the whole thing. Okay.